Hello! In this final lesson of the week, you will learn how to use Spark with Python. You are already familiar with basic concepts and abstractions, so now it is time to flesh them out, and we will start with using Spark in the local mode, just to avoid all the cluster-related issues in the beginning. Your first goal is to get used to the API provided by PySpark, and then by the end of this session, we will see how to migrate from the local mode to the cluster mode. Let's get started. First thing you need to do is to install Spark locally. You can follow the link in the slide to get the most recent instructions. At the time of shooting this video, local installation was as simple as downloading and extracting a tarball. Once completed, just go to the extracted directory and run the bin/PySpark executable. If you have IPython installed, you can use it as well by running the command in the slide. PySpark will load in a couple of seconds and you will be presented with a prompt, as shown in the slide. This prompt is a regular Python interpreter with pre-initialized Spark environment. Remember, we were discussing the Spark context object that orchestrated all the execution? In PySpark session, the context is created for you, and you can access it with the SC variable. SC stands for Spark context. When running in the local mode, the context will have the master property equals to something like local star, as in the slide, which means that this context is using local executors that are threads within the same process. When running in the cluster mode, the master URL will point to the cluster manager service like Yarn or Mesos or a standalone Spark cluster. Okay, let me show you how to create an RDD. Remember the example of the in-memory array? There is a built-in method to create an RDD from a list. It is called parallelize. Here in the slide, I have created the RDD A from a list of numbers from 1 to 5. Note that when I print the A variable, it says that it is a parallel collection RDD and not the list of numbers. This is because RDD is merely a descriptor for your data. I can query the number of partitions in this RDD by invoking the getNumPartitions method. In my case, it says there are 4 partitions. Now, as we discussed, to collect the data in the driver program, I have to invoke the collect action. Actions, as well as transformations, are just methods of an RDD object. So I invoke the collect action and, unsurprisingly, it returns a list of numbers from 1 to 5. To complete this example, let me show you how to apply transformations. As I said, transformations are methods of an RDD object. So I invoke the map method and pass the lambda function which doubles the input number. Again, note that the result of the transformation is an RDD. To compute the actually transformed dataset, I have to invoke the action once again. To demonstrate the laziness of RDDs, let me pull one trick. I'm going to do something which I told you should never do in your code. I'm going to create a side effect in my mapping function. Here, I pass the lambda function that prints the input number, doubles it, and returns the new number. Note that as I am running in the local mode, if my lambda function were invoked, when I apply the transformation, I would see my original numbers on the screen. To see the numbers, I have to invoke the collect action. It triggers the computation, hence invoking my lambda function, hence printing the numbers. Note that numbers are permuted because the mapping is done in parallel. Let me reiterate, this is an illustrative example. You should not create any side effects in your transformations for the reasons discussed already. Okay, I think it is a good idea to make a break here. You have learned how to start a PySpark shell, create RDDs from lists by using the parallelize method, invoke the collect action, and apply the map transformation. I encourage you to stop the video now and go and try everything by yourself. You cannot really learn how to program by watching the video. You have to practice, to experiment. Make sure you can reproduce every command presented in this video before continuing to the next one. See you!